Welcome back from the Amazon forest, guys. So in the last video, we find what is the term in terms of sine. We find alpha in terms of sine, cosine, and we find all of that. And now we just plug it in. We're gonna black on this, jungle or this whatever forest in. So the original differential equation is y prime minus 2 alpha times cotangent of theta plus 2 alpha equals 0, right? So what do we have? We have all of that stuff. Okay, I'm going to copy it. It's fine. I'm going to copy it, Sine theta. I'm going to copy it for you guys. Times cos theta c plus 2 with the power highlight. Everything is possible. And then I'm going to make it, clear. I promise. Theta to the power of b times cos theta to the power of c times negative abc minus ab plus sine theta to the power of b times cos theta to the power of c times negative abc minus ac plus sine theta to b plus 2 times cos theta c minus 2 times negative ac plus ac square. Okay, that is not bad. This is negative alpha prime negative 2 alpha cotan. I'm going to check the highlight. Okay, there we are. It would be negative. It would be, I'm going to add sine theta. Yeah, he's tough. I'm gonna say it over again. Yeah, just add the minus sign. I forgot to add the minus sign for y'all. Cos theta to the power of c plus 2 times negative ab. Oh my god. Yeah, I wonder, okay, and then where were we? And then negative and negative is positive, so this is AC. Okay, so remember, guys, this is negative sign right here. So I forgot the coefficient. I forget the coefficient already. What is that? Where are we? Sine b cos c minus 2. Okay, sine phi to the power b cos theta to the power c minus 2 times AC, right? AC, right? Is it AC? Yeah, it's AC. And add 2 theta, which is apparently sine theta cos. Then, okay, plus sine theta to the power of b times cos theta to the power of c times 2a equal 0. Now, this jungle is kind of insane, right? So how are we gonna do this? And then at first I think we're gonna find the simple case first. Okay, so how do we find a simple case? We know that a is cannot be 0. Okay, let me call this equation 10. Oh, I have so many things to do. Like, I will be out of my mind. Like, oh, sorry, guys. This is too much. Like, this costs more time than I thought. But okay, let's see what do we have. Okay, b equals 0. First case. Okay, I'm gonna write it in this. B equals 0. So what will we have? Okay, b equals 0. Let's see which term we can cancel out. The first term, yeah, we can cancel out, so I'm gonna put a dot here. Second term, we can also cancel out. B equals 0. Third term, no, we cannot. But what we have? We will have cos theta to the power of c times negative AC, because sine phi to the power of 0 is just 1, okay? This term can we cancel out? No, we cannot. And then what we have? We have sine phi to the power of 2 times cos theta to the power of c minus 2 times negative AC plus AC squared. Okay, this term we can cancel out. Yes, we can. Apparently, let's be here. And then we add, okay, we can cancel out that term, but we can reduce sine phi b to only this term left. And then the last term, can we cancel out? Yeah, we can. Cos c times 2a, because sine to the power of 0 is 1. So, okay, let's see if we can do any grouping. Apparently we can group cos theta up c. Here we can say like I can group to the power of c to 2a minus ac. Okay, I'm gonna group this one, okay, and then I say cos theta to the power of c minus 2 ac. The goal is we have to set it equal 0, right? Yeah, because equation 10 is equal to 0. And plus sine theta to the power of 2 cos theta to the power of c minus 2 times negative ac plus ac squared equal 0. So my guess is, I guess like all the coefficient here have to be equal to 0 in order for it to be 0. I think so. Let's see, because there's no other way it will cancel out. Like there's no magic number. Like it have the let me explain. So on this blue coefficient here, you see, have to be 0. Okay, it must, or it can never cancel out. So let's solve this system of differential system equation. Okay, so see, you see this equation, AC equals 0. So what you have, C equals 0, because remember A cannot be 0. Okay, so C equals 0 in this case. You plug it back to here, you have nothing. You cannot solve for A. Alright, but if you plug it in here, 2A minus A times 0 equals 0, you have A equals 0. Nonsense, we cannot solve for it. Okay, we cannot, remember, A cannot be 0. Okay, so this solution is futile. Okay, you cannot do anything. Or I mean, this is where the guess come in. I mean, apparently there's a lot of way you can set this. Apparently this billions of way. I'm not gonna lie, there's billions of way you can set this equation equal to 0. Actually, let me try another way. How about let me divide all of this to cos theta to the power of c minus 2. So let me denote this equation 11. I say divide everything. Divide 11. So say 11 over cos theta to the power of c minus 2. What is it equal to? Equal to cos theta to the power of 2 times 2a minus ac plus ac, right? Plus sine theta square. Okay. Okay. Well, God. This sucks, like honestly. Let me see. What did I do? This is, oh, okay. Yeah. Negative AC plus AC squared equals 0, right? Okay. Actually, we have an interesting result here. So the only way for this to happen is, I think, the only way for this to happen is let's say that I say 2a over ac over negative ac plus ac squared equal to 1, okay? The only way is you have to get this, okay? The only way for that to happen is you have to, actually you can, this is kind of interesting. You know that sine theta square plus cos theta square equal 1, right? So if you want to generate this result, this coefficient and this coefficient have to be equal so that you can factor out, you know, sine theta square and cos theta square. Okay, so let's do it. So I'm going to set 2a minus ac equal negative ac plus ac square. I'm going to divide both sides by a because a is not 0. 2 minus c equal to negative c plus c square. So c square minus c plus c minus 2 equals 0. So we have c square minus 2 equals 0. So we have, oh my god, c equals square root of 2 and c equal negative square root of 2. Now let's see what we can factor out. Okay, and then we find a. Okay, so substitute in c equal, let's say, like for example, I'm gonna replace 2a minus ac with, oh no, I'm gonna do something simple. I'm gonna replace negative ac plus ac squared. I'm gonna let it equal to 2a minus ac because we already said it. We said it equal, right? You see, and then we can factor out. Okay, so let me see. This is 12. So 12 would become cos theta square times 2a minus ac plus sine theta square times negative, oh no, I have to replace it. I replace it, okay? 2a minus ac. Okay, I replace, you know, from negative ac plus ac squared because we say they're equal. We set up an equation that it favor our direction, favor our constraint, okay? Plus ac equals 0, okay? So I'm going to factor out this, right? You see we can factor out cos theta square plus sine theta square plus ac equals 0, okay? So this is apparently cos square plus sine square is 1, so 2a minus ac plus ac equals 0. And then what do you have? 2a equals 0. Impossible, right? Impossible. Now, if that's the case, b equals 0, we dismiss it, okay? B equals 2 is not, because b equals 2 led to something which is nonsense. So on the chain reaction is wrong. Everything's wrong. If you lead to someone in mathematics, sometimes that's why mathematicians always they always look for perfection, right? If you can find one wrong in the whole derivation, everything is wrong. But once it's true, one statement is true, it's true for every cases. Perfection, isn't it? Like engineering, that's a weird concept. We know that's not ideal, you know, we know that in reality things, you know, get, you know, influenced, get disturbed, you know, nature get disturbed all the time. But yeah, so this is b is not equal 0. This case dismissed, you know, the judge would say so. I'm gonna try a different game. I'm gonna say c equals 0. What happens? C equals 0, okay? Let's see, we can simplify the term. So c equals 0. Let's go back to 10 and see what term we can simplify. Okay, the first term we cannot simplify. Second term we cannot simplify either. Third term we can. Okay, let me write down. But so we will have, okay, what will we have? Okay, I'm gonna use, oh God, I need to take photo of this. Actually, let me go ahead and take photo of this so that I can write to y'all. You know, I can look at the photo and write to y'all. Okay, let's see. So c equals 0, right? The first term, we cannot cancel out, but we can become sine theta b minus 2 cos theta square times ab square minus ab plus next sine theta b times cos theta to the power 0 is 1, and then term negative ab, right? Plus okay, same, this is sine theta to the power b times negative ac. Oh no, negative ab, sorry, negative ab. Oh no, it cancel out. Actually, it cancel out. The third term cancel out. Yeah. The fourth term also cancel out. Okay, good. I love it. I love things cancel out. And then add sine theta to the power b minus 2 cos theta to the power of 2 times negative ab. Okay. And then the sixth term cancel out. Then add sine theta to the power b times cos theta to the power of c times 2a equals 0. And we're gonna do the same thing. We're gonna count this equation 13. I'm gonna divide equation 13. I'm gonna divide by what? I'm gonna divide by, let's say, c sine theta to the power b minus 2. What will I get? I will get cos theta to the power square times ab square minus ab plus sine theta to the power square times negative ab, okay, plus cos theta to the power square negative ab plus sine theta square times cos theta to the power c times 2a equals 0. Okay, I'm gonna factor out some term. So cos theta square times ab square minus 2ab plus sine theta square oh, actually, is c equals 0? Oh, c equals 0. This one should be 0. This one should be this should be 1. Oh my god, I'm sorry guys. This should be 1. Yeah, so sine theta square times negative ab equals 0. Okay, so how does, if you want this to be equal, the only way, okay, the only way for something like this to equal 0, okay, is, of course, wait, let me see. I think I did something wrong. Oh, I forgot to add. Okay. I'm sorry. It should be negative ab plus 2a. Okay, so add the term. This term here, this term here, this term here, and this term here. Okay, add them. So, okay, the only way for this to equal 0 is the coefficient of each have to be equal 0. Okay, that's the only way, because think about it. There's no other way. You wanna cancel out a variable, right? If it times 0, it would be 0. It would times 0 would be 0. Okay, for on theta, whatever theta you are, theta can be can be 90, can be 180, can be bisexual, can be gay, less, anything. It will be 0. Okay, so how do we solve this? we know that a cannot be 0. So we divide both sides of the equation 14 and equation 15 by a. So we have b squared minus 2b equals 0. And then we have 2 minus b equals 0. Okay. So what will we have? So b times 2 minus b equals 0. 2 minus b equals 0. In order to satisfy both of this, 2 minus b have to be 0. So b equal 2. So we have what? We have c equals 0, b equal 2. And since a doesn't matter, right? You see how a doesn't matter? Like, a does not matter at all. So you can pick a equal 1. Like, you can pick a equal 1. I'll explain to you later. So our alpha, you remember alpha? Alpha is a sine theta to the power b cos theta to the power c, right? With that being said, a equal 1, b equal 2, c equal 0, alpha would be sine theta square. And this is how I think Dr. Mehmet got the result. Like, sincerely. Like, honestly. So now, why say a equal 1 with, like, you know, a equal 1? Actually, a can be anything. A can be anything. If you trust me, this is an exercise for you. So, okay, I want you to plug in 3 of these values. I want you to plug in 2 sine theta square, alpha equal this, alpha equal 3 sine theta square, alpha equal, 4 sine theta square, and then theta equal to k times sine theta square. K is a constant. Try to plug in this into equation 17 and see if you get 0. You find out that for this case of alpha will get you 0 no matter what. So alpha equal to a number times sine theta to the powers sine theta square, right? And we, as student, mathematician, physicist, a human being, we don't like complicated stuff. So we pick k equal 1. So in other words, alpha equal to 1 times sine theta square. That's it. I think that is the conclusion of the discussion of this differential equation. Actually, I think you are really tough. Like Dr. Mehmet, if you're watching this video, you are a hero. Like, I cannot imagine go through all this process. Like, thank you so much for doing that for me. It means a lot. Like, it means so much. I'm not gonna lie. Thank you so much. I wish you the best in your teaching journey and keep on being an amazing person. And to all readers that watching this video right now, I want you to get inspired. And I want you to explore, like, there's a lot of guessing technique. There's a lot of ansatz, right? There's a lot of ansatz technique out there that waiting for you, okay? It's really cool. So, again, thank you so much for watching my videos. I will see you guys sometime. Bye-bye.